Hello, this is Ghani Ahmed with you. This is lesson 4 in Objective-C, programming on Macintosh operating system. And on this in this lesson, I'm going to talk about how can we add or do arithmetics on number of variables. And in this lesson, we're going to see how also fiddle with all those variables. Okay, so in this lesson, okay, I have, for example, this is Apple price here, should be, and I'm talking here about like someone who wants to pay for like 7 kilograms of apples, okay, and he has to pay for this price, price rating, which is $5.5 whatever per kilogram. Okay, now we start with a cost of 0, of course, but later I'm going to set the cost as apple price times the apple weight. So this is how I multiply the numbers. You can, for example, later if you want to do something regarding addition, you put plus, subtraction, put minus. Okay, division is this. Okay, yep, so this is basically it. And because cost is a float number, okay, I put a %f here and just print cost equal this, and therefore when I run it, I should get this 38.9. Now if I want to also just put the decimal, so I should put 2f, just 2f like here, and I get it like just 2 decimals, okay, after the decimal point. Now and I can do more than that. So for example, I can do this like everyday math, and for example get maybe like this and this, and maybe get x itself, so x over times or plus, for example, 3. Okay, that also works because you can transform integer into a float. Okay, but the other way around, we'll see what will happen. Okay, so for example, this is cost now, and this is all about it. So simple, not a big deal. Okay, now it's preferred that you always keep the results of your arithmetics on a separate variable and then put them in here. Okay, put them on the printf. So you can separate printf from the arithmetics. Don't put the arithmetics itself. Okay, it works, but don't put it like this part. Okay, I will copy it and paste it instead here. Okay, let's see. See, it works. Cool, but it's not acceptable because this is annoying for you when you read it. Okay, now this cost. Arranging the code. Now what if I want to get just the decimal part, the fractional part of the number, of a float number? What I should do? I should first, for example, get x, which is an integer, and then set it to the float. So apple apple price, because price has a fractional number. So if I put it like this, I can later say printf, because x is currently 4, it's set to 4. Now I here set it to apple price, but apple price is a float number, but x is an integer, so it should take only integers. Okay, so therefore x is %n, %i, I mean. Okay, and then this is x. So here, if I run this, you will see x. By the way, I must put a slash n maybe here, okay, so I can break the line and see x is 5 and x was 4. Now you give it 5 point something, but x doesn't take floating numbers, doesn't take decimal parts, only takes the integer part, so therefore I can get 5. Now if I want to get the fractional part, okay, for example, I can locally here do this float fractional part. I can do this, define a local variable. This is local to the function main here, to the paragraph int main. Okay, this is a whole block, currently highlighted one. This is a function. Okay, later we'll talk about functions, but this is the fractional part, and then I can say that apple price, because apple price is bigger than x, minus x. Okay, and therefore I can print, for example, here fraction fractional is here, it's an f, and therefore I print fractional part. Okay, and this way I can get the fractional part only. Cool. And for more readability, put it as 2f. Okay. Now next is integer division. Okay, now I have y is 37 and x is 4, okay, or 5 here, but let's say I want to disable all this and use the variables from the top. Okay, so and we will be using, okay, like the division variable to save y over x. So division equals, okay, y over x. Cool. Now, and the remainder, because this is an integer division, you don't like get fractions. Okay, in integer Euclidean division there is no fractions, so there are remainders. So remainder, remainder, integer remainder. I'm defining here a local one, remainder. Okay, so division. Okay, not division, sorry. It is y percent x. So this is what's the remainder of the division of y on x. So this means what we call in math terms the modulus. Okay, modulus. Okay, so to print that out, I'm gonna put like this and remove this one. Okay, so of course the remainder must be an integer. Okay, so I'm going to run this, and this is my division. Okay, and this is my remainder. Cool. Now the good thing about modulus is that you can use it in rotations. Okay, like I mean always the remainder is like repeats. Okay, it repeats all the time. So like every time you divide by the same number, okay, however you increase the number, the remainder, okay, will always repeat itself. Okay, so like you are dividing by 3, so you will starting with the remainders 0, 1, 2, then the next time it will be 0, 1, 2, again 0, 1, 2, 0, 1, 2, forever. This is however big is y according to our code. Okay, however big the y, okay, with a fixed x, you will get the same set of remainders. Okay, and they are always x the biggest number is x minus 1, okay, because you're starting from 0. Okay, we will, for example, some time ago when we reach loops, we will show you something about, we might show you something about the modulus and the repetition. Okay, so I hope you enjoyed this lesson. Please your comments, and please subscribe. Okay, it's important to subscribe to the channel. Okay, so you can follow the the videos and the updates. Thanks.